Okay, Assalamualaikum. Alright, in the previous lesson, you already know how to find the. Okay, Assalamualaikum. Alright, in the previous study, in the previous lesson, you have learned how to find the discrete dan juga continuous joint probability distribution and also its marginal distribution. Okay, and then today we proceed with the next topic, which is how to find the conditional distribution for discrete and also continuous when we have bivariate random variables. Okay, semacam sebelum ni, before this, you have learned how to find the conditional probability, kan? This is the formula to get the conditional probabilities when we have two event here. So, kita akan guna pakai this idea to find the conditional distribution of the two random variables. Okay. So, to find the conditional distribution of y given x, okay, it will be the joint PDF divide dengan the marginal of x. Okay, y given x, so it will be fxy divide marginal of x. Untuk cari conditional distribution of x given y, the joint function divide dengan marginal h. Okay, konsep dia sama macam nak cari probability, a conditional probability. Tapi sekarang kita nak cari conditional distribution, so we deal with the function. Okay. Alright. So let's say, kita tengok terus example. Okay, ini untuk discrete. Okay, from the previous example 3.14. Find the conditional distribution given that y equal to 1, okay, and then use it to determine the probability of x equal to 0 given y equal to 1. Okay, so in order to find this, probability, we need the conditional distribution for x first. For x given y. Sebab apa? Sebab kita nak cari probability of x given y, so kena cari distribution for x given y. Given y equal to 1, sebab kat sini dia nak probability of given y equal to 1. Okay, in fact, you boleh cari probability of x given y equal to 2 and so on. Okay. Alright, so you know how to find the marginal of y, or marginal of y equal to 1. Okay, macam sebelum ni lah, let's say in the previous example ni, let's say this is your x, this is your y, okay, and then total of y here will be the, total of x here, kan, ni x. Let's say 0, 1, 2 here. So total of this will be, di sini y, bukan x. Kan, sebab kita totalkan y ni. So it will be, here will be hy, kat sini will be gx. Right? So total of this will be 1. So means that nak dapatkan marginal for y, this is the marginal for y. Marginal distribution for y. Kat sini adalah marginal distribution untuk x. Okay, so sekarang ni kita nak cari conditional distribution for x given y equal to 1. So it will be, okay, function of x given 1. Conditional distribution of x given y equal to 1. Okay, y equal to 1. So it will be fx1 divide dengan h y equal to 1. Kat sini h y equal to 1. Kat sini f x, y, 1. X kat sini, it can be 0, it can be 1, and it can be 2. Okay, kalau kat sini terus buat x equal to 0 pun tak ada masalah. So, kat sini will be x0 terus lah. Okay, macam ni kan, nak cari probability. Okay, so sekarang ni nak cari distribution of x, all the x given y equal to 1. So, you kena buat 1 by 1. Okay, so kat sini fx1. Macam mana dapatkan fx1 here? Fx1 here dapat daripada function di sini lah. Let's say kat sini. X kat sini 0, 1, 2. Okay. X kat sini 0, 1, 2. So here will be, kat sini, it can be fx0, y1, fx1, y1, dan fx2, y1. Divide dengan hash y equal to 1. Okay, so because of that, this is. Ini untuk x equal to 0, x equal to 1, x equal to 2. Tapi untuk y, it's still 1 lah. Okay. So, we got this. So, ini adalah distribution, conditional distribution given that y equal to 1. Okay, soalannya nak dapatkan property of x equal to 0, y equal to 1. Boleh terus dapat daripada sini. Kalau you buat dalam bentuk macam ni lah. Kalau tak, let's say kalau you nak cari this probability saja kan. X equal to 0. Sorry. Not x. It is p. And it is p pun boleh sebenarnya. P boleh ataupun f pun boleh. Okay lah, I buat p, comma, y equal to 1, divide dengan h, y equal to 1. So, p, property of p01 ni kena tengok balik you punya 3.14 sebelum ni. Cuba check 3.14 dekat page 115. The answer px0y1 adalah x0 and y equal to 1. It is 3 over 14. So, di sini will be 3 over 14. This is the probability of x0, y1. You check daripada distribution table. Kan? Divide dengan marginal of y equal to 1. Marginal of y equal to 1 adalah 3 over 7. 3 over 7. So, last kali you akan dapat 7 divided by 14 ataupun 1 over 2. Okay. So, that is the way how to find the conditional distribution untuk discrete. Okay, let's say ini I tunjuk. Okay. This one. Okay, ini untuk continuous. Okay, this is the function and this is the interval. Okay, seems here the intervalnya adalah overlap between x and y kat sini. Okay, find the marginal of gx dan hy and the conditional density fy given x. Okay, in order to find the conditional density function, we need to have the marginal function first. Okay, kena cari marginal function of x actually, kan? Because of fy given x equal to fxy, the joint function, divide dengan gx. Okay, fxy dengan fyx sama lah kan? Okay, divide dengan gx. Di sini. Okay, so fxy adalah this function is the joint function of x and y divide dengan marginal of x. So, because of that, we need the marginal function first. Tapi kat sini dia tunjuk dua-dua untuk marginal for x dan juga for y. Okay, so macam biasa, nak dapatkan marginal for x, you need to integrate the function with respect to y. So, y dekat sini, dia punya, apa ni, dia punya interval from x to 1. Okay, then integrate macam biasa, integrate this function with respect to y, and then replacekan x dan 1 dalam y. So last kali you akan dapat this. Okay, and then untuk dapatkan marginal for y, you integrate the joint function with respect to x. So the the interval for x adalah from 0 to y. Okay, integrate with respect to x here, replace 0 and y in x, dan you akan dapat this function untuk marginal y. Okay, so once we have these two value, and we know that this is the joint function of fxy, so this is 10xy square divide dengan gx. Gx is this one, 10 over 3x, 1 minus x power of 3 here. And then solvekan. So ini adalah conditional function of y given x. Untuk y given x. Boleh juga you cari untuk f x given y. So you have fxy divide dengan hash y. So 10 xy square divide dengan 5y power of 4. Okay, untuk dapatkan conditional density untuk x given y. Okay, soalan yang kedua. Find the probability that the spectrum shift more than half. Okay, so kita baca sikit ni tadi pasal apa. The joint density of the random variable xy, where x adalah the unit temperature change and y adalah proportion of the spectrum shift that a certain atomic particle produce. Find the probability that the spectrum shift more than half of the total observation, given that the spectrum shift adalah y. Okay, y more than half. Okay, y is more than half of the total observation, given that the temperature is increased by 0.25. So temperature adalah x, when x is 0.25. So this is the probability that we need to find. Probability of spectrum tadi more than half, given that the temperature is 0.25. Okay, so in order to find this problem, we need to find the conditional density function first. So because of that, tadi kita kena cari dulu this function. Kena cari dulu this function, nak solve untuk probability. Y given x, y given x. Okay, so we have this function. We have this function. So nak cari probability of y more than half given x equal to 0.25. So you kena integrate, nak cari probability untuk continuous kan, kena integrate. Kena integrate which function? Kena integrate lah function ni lah. Sebab kita nak cari probability of y given x ni. So kena integrate function, conditional function of y given x. Okay, from where to where? With respect to mana you nak here, dy ni depends pada you nak cari probability apa. Kat sini, sebab kat sini nak cari probability, because of here we want to find the probability of y. So kat sini you kena integrate with respect to y. Kalau kat sini nak cari probability of x given y, so kat sini will be integration of the function of integration the conditional function of x given y, okay, with respect to x. Okay, kalau you nak cari probability of x here. But now for this example, because of you want to find the probability of y given x, so kat sini you kena integrate the conditional function of y given x with respect to y. Okay, so kena integrate this function with respect to y. Okay, sorry, not this. Ini kita dah siap, kena integrate this function. Okay, saya buat sini satu lagi. Okay, the function is 3y square over 1 minus x power of 3 dy. Okay, kena integrate this function, which is the conditional function of y given x with respect to y. Okay, and then dia bagi x equal to 0.25. So because of that, you kena gantikan x kat sini dengan 0.25. Baru you integrate. Okay, gantikan dulu X with 0.25. Then you integrate with respect to Y. Gantikan dulu X equal to 0.25. Barulah you boleh integrate with respect to Y untuk dapatkan the probability. Kalau tak, dia akan ada in terms of X. You nak integrate terhadap Y. X ni akan jadi constant. So last kali you punya function, last kali you tak akan dapat probability, you akan dapat function juga. Sebab in terms of X kan. So because of that, you kena gantikan X ni dulu dengan 0.25 baru integrate with respect to Y. Okay, dan macam biasa, integrate with respect to Y, then replace Y with 1.5, you akan dapat the probability. Okay, so that is the way how to find the probability of the conditional function dan juga conditional probability. Okay, let's see one example. Ini contoh sama juga, dia bagi contoh. Okay, you can go through nanti. Okay, let's do one example here. Okay, so this is the joint function xy. Intervalnya x0 to 1, y from 0 to 2. Okay, first find the marginal distribution for x dan y. Okay. Okay, so nak cari marginal. Nak cari marginal for x will be integration of the function. Okay, I letak 1/4 kat luar sebab 1/4 is constant. Okay, 9 minus 6x minus 6y plus 4xy divide, tak perlu divide lah sebab ada letak kat luar. Okay, terhadap, okay, with respect to y. Okay, so integrate that from where to where. So, kena ambil limit untuk y, which is 0 to 2. Okay, so what to do here? When we integrate 9 with respect to y, you akan dapat 9y minus 6xy minus 6y square divided by 2 plus 4xy square divided by 2. Then replace all the y with 2 minus, replace pula y equal to 0. Okay. So the first part, when you replace y with 2, you akan dapat 18, right? 18 minus 12x, right? Minus 3 multiply 4, you will get 12 plus, so here will be 2y square, so will be 8x minus dengan replace pula y with 0, so you akan dapat 0, right? Okay, so last kali, finally you will get 1/4, 18 minus 12 will be 6, and minus 4x, right? Okay, this is the marginal for x. So we need to put the interval for x, 0 and 1. Okay, this is the marginal for x. So you need to proceed with the other one, which is the marginal for y. Where should I put this? I think we need another. Saya buka pen lah ya. Sekejap ya. Sebab tak muat. Okay. So we need to find another one adalah marginal for y. So we need to integrate the PDF function with respect to x. Okay. So here we need to find the hash y. Okay, integration of the function. I put 1/4 juga kat luar. Okay, 9 minus 6x minus 6y plus 4xy. Integrate y terhadap x. Okay, x is from, the limit is 0 to 1. So it will be 1/4 9x minus 6x square divided by 2 minus 6xy plus 4x square y divided by 2. And we replace x with 1 dan 0. So what you will have when we replace x with 1, you will get 9 minus 3 minus 6y plus 2y. Okay, and then another one, minus dengan replace pula all the x with 0. So you akan dapat 0. So 5 seconds sikit. So apa yang dapat kat sini will be 1/4 6 minus 4y, right? And then should put dia punya interval for y. Okay, so we have this hash y. Okay, and then we need to find the okay, yang kedua, nak dapatkan conditional density function of x given y. Okay, conditional density function of x given y. So it will be f xy divided dengan marginal distribution for y. So it will be 9 minus 6x minus 6y plus 4xy, which is the joint function for fxy, divide dengan marginal function for y. Sorry, kat depan ni ada 1/4 kan. Okay, divide dengan 1/4 6 minus 4y. So the marginal function will be, the conditional function will be 9 minus 6x minus 6y plus 4xy divide dengan 6 minus 4y. So this is the conditional function of x given y that we have. Okay, the next question is nak cari probability of x less than or equal to 0.5 given y equal to 1. So in order to find this probability, we need the function. Sebab nak cari probability, Nak cari probability, kita kena integrate. Nak integrate function mana? Nak kena, in this case, kena integrate function conditional function of x given y. Because of this. Okay, so because of that lah, kena cari dulu f(x) given y. Okay, so we have tadi, we have the conditional function x given y tadi. Kita nak cari, so nak cari probability of x less than or equal to 0.5 given y equal to 1. So means that we need to integrate the function of x given y equal to 1 terhadap with respect to x. Kita nak cari probability of x less than 0.5. Okay, x less than 0.5. So dia punya limit nak ambil dari mana ke mana? Okay, dari mana ke mana? Kena tengok juga limit x ni. Okay, kalau dia daripada negatif, kena tak negatif lah. Tapi kat sini bermula daripada 0. Because of kita nak x less than 0.5, maksudnya 0.5 and above. Okay, so limit dia punya lower limitnya will be start dengan 0. Start dengan 0 until 0.5. Okay, so what is the function? This function, then replace y with 1. Okay, 9 minus 6x minus 6 gantikan y dengan 1 plus 4x gantikan y dengan 1 divide dengan 6 minus 4 gantikan y dengan 1 integrate with respect to x. So now once we replace all the y with 1, so you akan dapat in terms of x sajalah. So 9 minus 6x minus 6 plus 4x. So it will be 3 minus 2x, right? Divide dengan 2 dx. Is it true? Okay, betul eh? So integrate lah macam biasa. Integrate the function. So will be 1 over 2 3x minus 2x squared divided by 2 and replace 0 and 0.5. So berapa dapat kat situ? 0.5 multiply 3 minus dengan 0.25 So it will be 1.25 here. So lastly, divide dengan 2. The answer is 0.625. Okay, so the answer, the probability of x less than or equal to 0.5 given y equal to 1 adalah 0.625. So remember, make sure nilai probability cannot be negative value and cannot be more than 1. So 0.625 is logic. Okay, so that is the way how to find the marginal atau the conditional, the probability of the conditional probability. Kita dapat. Okay, so sikit je lagi saya nak tunjuk satu lagi regarding the condition of the independency. Okay, so using the marginal juga, kita boleh tahu whether the two variable is independent or not, which is using this definition. So you kena hafal this. Okay, nak tahu whether x and y are independent or not, we need to fulfill this condition. Fxy equal to the joint function of xy equal to the marginal of x multiply the marginal of y. Okay, as simple as that. Okay, contoh yang ni tadi, yang ni. Okay, let's say here we have fx01. and we have the marginal of 0. Marginal of x0 is 5.14 dan marginal untuk y equal to 1 is 3/7. So kita nak check kat sini dari x dan y, nak check whether x and y are independent or not. So kalau untuk discrete, we have many pair of x dan y, kan? So you boleh pilih mana-mana pairing saja untuk check whether these two variable is independent or not. So boleh pilih mana-mana pairing. So sekarang kat sini dia tunjuk untuk pair of x0, untuk pairing of x0 and y equal to 1. So kita nak guna this pair, so kena cari, kena tengok dia punya probability of when x equal to 0 dan y equal to 1, which is 3/14. You boleh tengok example 3.14 tadi dekat page 116. Okay, and then in order to check for this condition, kita kena ada marginal. Marginal pun ada banyak. Beberapa kan, marginal untuk x0, marginal untuk x1, marginal untuk x2. But because of here, kita gunakan x is equal to 0, so kena ambil marginal untuk x equal to 0, which is 5/14. Boleh check balik dekat page 116 kat situ. Okay, dan juga marginal, kena dapatkan marginal untuk y equal to 1. Ni marginal x equal to 0, ini marginal y equal to 1. Because of this, kita ambil y equal to 1. Okay, so how to check this? Just check bila marginal x equal to 0, multiply dengan marginal y equal to 1, dapat sama tak dengan the joint function when x equal to 0, y equal to 1. So you multiply these two, 5/g0 multiply h1, which is 5/14 multiply 3/7. Berapa you dapat kat situ? You akan dapat 15/98. Okay, dan the joint function of x0, y1 is 3/14, which is not equal to this value. So we can make the conclusion that x and y are not independent, are not statistically independent. Okay, so itu untuk discrete. So boleh jugalah kalau you nak check guna pair yang lain, contohnya nak check gunakan fx1 y2 pun boleh. Tapi kena comparekan dengan multiplication of marginal x equal to 1 dengan marginal y equal to 2. Multiply these two, dapat tak sama dengan the probability of x1, y2. Okay. Okay. Ada tak contoh untuk tak ada contoh untuk untuk continuous. So let's see this example. Okay, so dia tanya kat sini, determine whether x and y are independent or not. Okay, let's see here. Sama juga, guna konsep yang sama. To check whether x and y are independent or not, kita boleh gunakan this concept. fxy should be equal to gx multiply hy. Okay, x and y independent, x and y independent if and only if this condition fulfill. Okay, so ini adalah fxy. Ini adalah fxy. Sekarang kita nak check the multiplication of the marginal of x dan marginal of y. So, apa dapat? So, try gx multiply dengan hy. Apa yang akan dapat? Gx adalah 1/4, 6 minus 4x. Okay, hash y pula adalah, okay, hash y tadi 1/4 6 minus 4y. Okay, 1/4. Okay, so apa yang akan dapat kat situ? It will be 1/16. Okay, 6 minus 4y, 4x, 6 minus 4y. So you need to multiply these two untuk tahu sama tak dapat kat situ. So, I rasa I nak padam dulu yang ni sebab aku tak muat. Okay, I padam yang ni dulu. Lambat pula kan. Okay, so kena buat, kena expand lah kan. Expand 6 minus 4x dan 6 minus 4y. Oh. So, I sambung di sini. So, it will be 1/16. 36 minus 24y minus 24x and plus 16xy. So, apa yang dapat dekat situ will be 1/16. Okay, 36 minus 24y minus 24x. Oh, okay. Okay, dia tak ada benda yang you boleh nak gabungkan. So, just bahagikan dengan 16. Okay, bagikan dengan 16. Simplify that. So, you akan dapat 9. Kan? 9 minus dengan 24 divide dengan 16. Okay, sorry, kat sini 9/4, right? Here will be, okay, 6x/4. Kita cuba jadikan dia 1/4 kan kat situ. Sebab kita nak jadikan dia macam ni. So, 6y divide by 4 betul. Plus dengan 4xy. No, tak sama kan? Over xy. So, seems that x and y are independent, right? Since this answer, which is the multiplication of the marginal of x multiply marginal of y, adalah 9/4 minus 6/4x minus 6/4y plus xy adalah equal with the joint function, which is this function. So we can conclude that x and y are statistically independent. So nak buat apa ni, nak panjangkan lagi pun boleh lah. Since f x y equal to hash y multiply dengan gx. Okay, so that's the answer.